Hey, today we're going to talk about empirical and molecular formulas. But before we do, I want you to get out your reference table because you should always have your reference tables handy every time you watch one of these videos. You never know when you're going to need some information. Okay, get it out. Now, we have a molecular formula, which you're familiar with. But we have something new today, and an empirical. An empirical formula. Now, a molecular formula is an example would be CH4, CO2, CH3COOH, and something like C6H12O6. Now, an empirical formula, all it really means is it is a ratio of one element to the other. So what you're going to do is you're going to total up the ratios and you're total up the elements, and you're going to simplify it into its simplest terms. Watch. CH4, let's take this one right now. So the molecular formula of CH4 of methane is CH4. When we write the empirical formula, there's no way to simplify it because we only have one carbon. For every one carbon, we have 4 hydrogens. We can't say we have half a carbon and 2 hydrogens. That just doesn't work. So the empirical formula is also CH4. Same thing applies to CO2. For every one carbon, there's 2 oxygens. The empirical formula is also CO2. So something like this, it's going to be the same. A molecular formula can also be an empirical formula, or an empirical formula can also be a molecular formula. Now when we do something like this, this is ethanoic acid, also known as acetic acid, also known as vinegar. We have 2 carbons. So let's just, so that's C2. We have 1, 2, 3, 4 hydrogens. And we have 2 oxygens. Now because these are all even numbers, I can divide by one common multiple factor. Multiple factor. The greatest common factor of C2H4O2 is CH2O. Okay? Now the next one that I have is glucose. Glucose, C6H12O6, you can divide them all by 6. 6 divided by 6 is 1, 12 divided by 6 is 2, and 6 divided by 6 is 1. CH2O. Do you notice something? Good. Ethanoic acid and glucose have different molecular formulas, incredibly different structural formulas, but they have the same empirical formula. Just because you have the same empirical formula doesn't mean you have the same, that you have the same properties. Now, how can we use this practically? Okay, a compound has a gram formula mass of 28 and an empirical formula of CH2. What is the molecular formula? Here's what you do. First things first, let's figure out the gram formula mass of this one. Now there's a couple ways you can go about doing it. You're going to get practice working on this. So I'm going to let you guys figure out how you want to do it best. The way I do it is I figure out C. We have 1 times 12, that equals 12. H, we have 2 times 1, and that equals 2. So this is 14 grams per mole. Now, CH2 is 14 grams per mole, but my compound has a gram formula mass of 28 grams per mole. How many times does 14 go into 28? So CH2 is 14, and X is 28. To get from 14 to 28, I had to multiply it by 2. So what I'm going to do is I'm going to multiply each one of these subscripts by 2, and it's going to give me C2H4. This is my molecular formula. Pretty straightforward. You'll get some practice, but before you practice on paper, you're going to practice right here.